This video is going to be a review of multiplication strategies that you can use to solve any multiplication problem. If you have a multiplication chart, you can use that to check yourself, but I really recommend that you try the problems on your own instead of relying on the chart to find the answer. But it's a good resource to check yourself because then you can see if you need to practice a certain problem or not. But anyway, I'm just going to jump straight into this. So a first strategy that you can use to solve multiplication problems is repeated addition. What that means is if we have a problem and say we have 3 times 6, we can think of multiplication in terms of just repeatedly adding. So that means we have 3 groups with 6 in each. So we can solve 3 times 6 by adding 6 plus 6 plus 6. If we do that, we can combine these two and get 6 plus 6 is 12, and then add on another 6. 12 plus 6 equals 18. So that's just one method that you can use to solve multiplication problems. I'll do another example just in case. Let's say we had 2 times, not 2 times, let's do 4 times 5. If we do repeated addition to solve this one, we would have 4 groups, and we are adding 5 4 times. We would get 5, 10, 15, 20. Another strategy that you can use is groups of. So say we had 7 times 3. This is very similar to repeated addition, but it allows it to be a little more visual if you like drawing the problems out. What we do groups of is we take our first number, which is 7, and we're going to draw 7 groups. So I have 1, 2, 3, 4, 5, 6, 7. Okay. Let me erase those dots. So now that we have 7 groups, we're going to put 3 in each. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And you'll get the total, the answer, by adding all these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Or if you want to practice your skip counting, you can, and we know that there's 3 in each, we can just go 3, 6, 9, 12, 15, 18, 21. We'll do one more example of groups of. We'll do 4 times 6. So we draw 4 groups. I'm going to put 6 in each. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to add them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Or if you want to skip count it, 6, 12, 18, 24. Our next strategy is drawing an array. So say we had 4 times 7. To draw an array, I look at my first number, which is 4, and I'm going to draw 4 circles down. My second number is 7, so that's telling me that each of these rows that I just drew the start of, there's going to be 7 in each. And now our first one, this first row, counts as 1. So I have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. And you can find the answer by counting all of these dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Or you can skip count by 4s or skip count by 7s. So if we counted by 4s, let me change colors, we would have 4, 8, 12, 16, 20, 24, 28. And if we were to skip count by 7s, we would have had 7, 14, 21, 28. So see, all these different ways you can do this and you get the same answer. So whatever strategy works best for you. We'll do one more array. Let's do 8 times 2. My first number tells me how many down I need to have. 1, 2, 3, 4, 5, 6, 7, 8. And there's 2 in each row. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Now I add them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You could have also solved this by skip counting by 8s, which would have given me 8 and then 16. Or you can skip count by 2s and get 2, 4, 6, 8, 10, 12, 14, 16. Again, multiple different strategies, same answer. Now, something we talked about with arrays is when we have bigger numbers like 6, 7, 8, 9, we can split the arrays into numbers that are easier to work with. So let's say that we had 7 times 5, and I'm going to draw the array for that, so I have 7 down. 1, 2, 3, 4, 5, 6, 7, and 5 in each row. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I have this array drawn, and I'm just going to draw a line through it, but I'm not going to change the amount of dots that are in it. So I'm just going to draw a line right here. And I did not change how many dots are in the array. I just put a line through it to split it up into 2 different smaller steps instead of one big one. So now my new array up here at the top, I have 1, 2, 3, 4, 5 down, and 1, 2, 3, 4, 5 across. So my new one is 5 times 5. And if I skip count by 5s, I'm going to get 5, 10, 15, 20, 25 for this section. The bottom one, I have 1, 2 times, and there's 5 across. 2 times 5 equals 10. So now I have my top section and my bottom section, and I'm going to put them together to get the answer of the whole array again. So it's like I took two pieces and I'm going to put them back together and do 25 plus 10. And that gives me 35. Now if I were to skip count by 5s 7 times, I would get 35. And if I were to count by 7 5 times, I would get 35 as well. We'll do one more with splitting arrays. We'll do 8 times 3. So I have 8 down. 1, 2, 3, 4, 5, 6, 7, 8. And 3 across. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Now I'm just going to draw a line somewhere in this. And I didn't take away or add any dots. I just split it into two smaller parts that I'll put back together at the end. Up here my new array is 4 times 3. And I can skip count. I can hold up 4 fingers and count by 3, or hold up 3 fingers and count by 4. I'm going to hold up 3 fingers and count by 4. So I have 4, 8, 12. You can also just count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. At the bottom I have 4 times 3, and I just solved that, so I know it equals 12. I'm going to take my two answers and put them together, and I get that 8 times 3 equals 24. And if I were to count all of these dots, I would get 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24.